Well, hello there and welcome, students. We are looking at log functions today, and we're going to go ahead and this isn't a really formal definition, but we're going to go ahead and say that a log is going to be defined if we have y equals log base b of x. We're going to say that that's the same thing as saying x equals b to the y. So we think, what in the world does that mean? Well, let's just look at a few logs and see if we can kind of make sense of what's going on. To me, a log asks the question, how many powers of my base do I have? So with our first example, we have log base 2, and that is log base 2 of 8 would be how we would say that. So how many powers of 2 is 8? Or in other words, if I were to rework with my definition, notice that let's go ahead and write this as log bx equals y, and we're looking for the y in this case. And we go ahead and use our definition to say exactly what that means. Let's see. My x in this case would be an 8 equals, and then it would be 2 to some y, with y being what we're looking for. So 2 to what power is 8? Why, this is 3. So that would be the answer to that one. So 2 to what power is 8? Or for this one, 3 to what power is 9? The answer to this would be 2. So you're asking the question, how many powers of my base do I have? 10 to what power is 100? Well, 10 squared is 100, so that answer is 2. In other words, your answer is the exponent. And if you'll look at this, indeed, your answer is the exponent. 10 to what power is 1,000? Well, that would be a 3. So we'll look at a few more of these. Okay, we're going to make these a little bit harder. We're going to look at these in terms of 2 to what power or 3 to what power. So if you'll remember, let me go back and do a little side work here. Remember that 3 to, let's say, to the negative 2 is the same thing as saying 1 over 3 squared, or 1 over 9. So if I remember that, that makes these a little easier. So 2 to what power is 1 over 4? Well, that would be the same as saying log base 2 of 2 to the minus 2, because 2 to the minus 2 is 1/4. So this exponent is negative 2. This one is 3 to what power is 1? In other words, we are looking at 3 to some power is 1. And what might that be? Well, that would be 0. 3 to the 0 power is 1. That's very interesting. This one, 1 over, is going to be a negative exponent, so it's negative 2. This one is the same as saying 1 over, and this would give me 1, 2, 3, 4 spots, so that would be negative 4. All right, that's kind of looking at some weird ones. We'll look at some more weird ones. Okay, this time they're given to us in a strange form. Well, you know what? I'm not really used to looking at logs, so what I'm going to do is I'm going to use my log and rewrite it according to my definition. So let's see what we have here in exponent form. 3 is going to be my base, so I'm going to write 3. The answer is my y, so I'm going to write negative 2 and then equals x. So just kind of seeing what goes where. This would be my b from up there. So this is my b, and that's not a really good arrow, but there he is. And then this would be my x, and this in that case would be my y, and I'm just putting them in the right form. This gives me x equals, and I just did this just a second ago. Negative exponent means 1 over. Let's look at this one. It's a little different, not a negative exponent, but it's a fraction. I'm not really used to that. So here's my base. So that's a 4. And it's raised to the 1/2 power, because there's my exponent, that's my y, equals x. And what is 4 to the 1/2 power? Well, that's the same as the square root of 4, which is just 2. Strange, all right, but that is what it would equal. Now, when I'm looking at logs and exponential functions, they are just inverse functions of each other. So we're looking at here, we're looking at y equals 2 to the x. So that's what we're looking at, y equals 2 to the x. And if I want to graph his inverse, I just flip-flop those x and y values just as we did previous to this. And I can draw it, and you'll notice that it is a reflection about the y equal x line here. And this is how all of my logs look, just like all of my exponential functions look like this guy here. All of the logs look like this one. So when you graph them on your calculator, you can find them under your math functions if you want log at any base. If you want log at any base, you'll have to hit math, and then you'll have to scroll, and you'll see in those functions, you'll see log base, I think is how it's written. And when you click on that, it should put you in the appropriate format to be able to punch it into your calculator so that you could graph these. On your calculator, you'll notice the LOG word. The LOG word is log base 10. We use quite a few things in nature that are log base 10. So if it doesn't have a base written here, you're to understand and assume that it is log base 10. You'll also see on your calculator an LN, and that represents natural log. And a natural log is one that occurs naturally, of course. And what he is another way to write log base E of x. So if we were looking at this one, I would rewrite it to be x equals e to the y. And this is my natural log. We just use this one so much that we just get lazy. So we don't write this anymore. Instead, we would just write natural log of x equals y. So we replace all of this stuff right here with just ln. All right. Now, working with logs takes a little bit of getting used to. You're not used to seeing that log. That log is just an operation. If you have any trouble with this, you be sure and send me an email, and I'd be glad to help you with this. We can do a collaborate with these as well. Just take some practice and getting used to. All right, y'all have a wonderful day.